Hello ladies and gentlemen, and thank you for listening to Mr. Laxton's video on these 5.3 geometry notes. Alright, today we're bringing back this word angle bisector. Okay, we've talked about that before in the first semester, definitely. Talking about bisectors is something that cuts an angle in half, right? But today we're talking about how do we use these actually in triangles. Alright. Perfect. So here, essential question today, if you need to pause the video to write these things down, please do. But what we're looking today is when do you know that a point is on that angle bisector? Okay, so we're looking, how do you know when it's actually on there? Okay, and a couple definitions here. If you want to pause, like I said, again, please do that. An angle bisector here is a ray that divides an angle into two congruent angles. All right, so if we have some sort of an angle here, this ray cuts it, and then this angle is congruent to that angle there. All right, so distance from a point to a line is the length of a perpendicular from a point to a line. All right, so that's just talking about the shortest distance from one point to that line is the distance from a point to a line. An inscribed circle is a circle that intersects each side of the triangle. So it hits here, and it hits here. All right, it intersects that triangle at some point. All right, the incenter is a big vocabulary word today, is the point of intersection of a triangle's angle bisectors. So if I look here, I have my three bisectors, and they all intersect at this point right here, so that this right here is my incenter, that point of intersection of all those guys. All right, so a couple theorems here. Theorem 5.5 is the angle bisector theorem that says if a point is on an angle bisector, of an angle, then it is equidistant from the two sides of that triangle. All right, so if I draw some triangle here, it says, hey, if this, let's say that this point is somewhere in here, all right, let's say that's point P, and we know this is the angle bisector, so we know, so I'm going to put kind of an if here, if it's on an angle bisector, then we know that, hey, this distance here that's perpendicular, right? We talked about that perpendicular. This distance is congruent to that distance. So this is kind of the then part here. All right. If it's on the angle bisector, then they're equidistant. Okay. So the converse is really just the opposite of that. It says if a point is in the interior, and it is equidistant from the sides of an angle, then it is on the bisector of that angle. Okay, so that's kind of the same deal here. If we draw this triangle, kind of the same triangle here, it's the same deal but just backwards. So that's saying if we have some point P that's in the middle here that is equidistant from these sides, so this side is congruent to this side, is equidistant. So this is the if part. Okay, it switches around. So then that means that, hey, this point right here is on that angle bisector. So this is the then part. All right. So that really just, it's the converse. It switches it around. All right. So then 5.7 is the concurrency of angle bisectors theorem. This says that if a point intersect at a point in the incenter, all right, so that if we go back up here to our vocabulary words, the incenter is this point where all the angle bisectors meet, that is equidistant to all of the sides. All right, of the triangle. So that means that, hey, this point right here, if I go back up here to my incenter, this point right here is the same distance here as the same distance here as the same distance here. So these are all right angles. These guys are all congruent to each other. All right, back up in that picture. Good. So now if we move on to kind of these examples here that are pretty quick and self-explanatory. This one says, hey, find the value of x and tell which theorem is used. Okay, so we kind of forgot to draw these in here. So this one says that, hey, these guys should be in there. So we know that, hey, this point right here is on the angle bisector. So then really that means that this has to be congruent to each other. And that's theorem 5.5. Okay, so that says, hey, if that point is on the angle bisector, then these sides are congruent to each other. All right, so let's set those guys equal to each other and find x. So I got 10x plus 10 is equal to 8x plus 20. I go through here, I minus the 10, I minus the 10, I minus the 8x if I'm going to do that in the same step. So these guys go away, these guys go away. So I have 2x is equal to 10. Divide by 2, I get x equals 5 here. Awesome. So good. And if I move on to B, this says, hey, these guys are the same. So this is congruent to this. So this is the converse. So this is theorem 5.6 here. It says, hey, if these guys are congruent to each other, then these two angles have to be congruent to each other as well. So 6x equals, change that into an equals here, is equal to that 2x plus 16. All right, so if I go through solve for x here, I minus the 2x, I minus the 2x, so I get 4x is equal to 16. Divide by 4, I get x is equal to 4 there for that one. Awesome. So there we go for those couple. As you flip over to the backside here to page 130, I'll scroll down through the worksheet here. It says point T is the in-center of the triangle. Okay, so that is the in-center. Okay, and it says that means that, hey, and I want you to write this next to it, the in-center, it means is equidistant, that doesn't spell distant, from each side. Okay, so what that means is that this length here is congruent to this length, is also congruent to that length. So that point in the middle is equidistant to each side. All right, so now it says, hey, what's the measure of ST? And I know that WT is 15, so I know that ST has to be 15 as well, because it's got to be that same distance. TU is also got to be that same distance, so TU is also 15. And then RU is kind of the tricky one here. This is 15. Okay, and we haven't talked about this a whole lot, but we have the Pythagorean theorem. So since this is a right triangle, we can use the Pythagorean theorem. And the Pythagorean theorem is a squared plus b squared is equal to c squared. So these are the two legs, A and B are the two legs, and then C is the hypotenuse. And I have here that if I look at this triangle right here, if I try to find RU, I know that 26 is my hypotenuse, and I know that one of the legs is 15, and I got to find this x. Okay, so let's call that angle, or that x there. So I'm going to say that x squared plus 15 squared is equal to 26 squared. All right, so now if I go through here and just figure these guys out, I can see that 26 squared is a large number. I don't have a calculator right in front of me. Let me grab that out. 26 squared is 676. 15 squared is 225. And then I still have x squared. So I minus this 225 to the other side, minus 225. So now I get x squared is equal to 676 minus 225, which is 451. All right. Now here to get this x squared out of here, I got to take the square root of both sides. So I get x is equal to 21.24 is the distance of my x there. All right, awesome. All right, so A3, I'm going to skip that guy for now, and then A4 is a good question as well, but you do need your compass for this. So I don't have a compass right off my bat right here, but it says you want to find a place to live that is the same distance from South Ave to Jackson Street to 16th Street. Okay, and you can't really see it here, but this one is Jackson Street. It didn't really copy out very well, so this one is Jackson. Now I have South Ave and 16. So let's draw those lines in there. This is 16th Street in Jackson. This is 16th and South, and then this down here is 16th and Jackson, or South and Jackson, excuse me. So what we have is we have this triangle that connects these guys, and I'll try to draw mine as nicely as I can here. Connect these guys. Awesome, and then go through Jackson right here. So what you have to do is you have to bisect these angles, okay? And we did this back in the first semester, and it's been a while since we did it, and that you can use your protractor to bisect these angles. So you can look back on here, and this is on page actually 28. It says how to bisect an angle, and you should have a blue little sheet in there. So bisecting is page 28 of your binder. And then it's going to show you how to bisect these. So if you bisect them, and I'm going to kind of sketch this in here since I don't have a protractor on this program that I'm doing this on, is that you can take this and you can bisect these angles. Let me see here. I think that if you bisect, it should go somewhere through here. This one should be somewhere through here. And then this last one is someplace through the middle of those. Okay, so what this bisector means is that, hey, this angle has to be congruent to this angle. This angle is congruent to this angle, and then this one gets those three. So this one has all three of them on it there. All right, so it asks you where's the place that you should live, where's the point that's equidistant from all those. You should live right here, okay, because that is the same distance here as the same distance here and the same distance here. So you're equidistant from all three of those streets. All right, so this guy right here is what we call the in-center. All right, so awesome. Your goal for the day here is to look at page 129 and 131. So if you have any questions on those guys, please find me. But take a look at those, see what you can find, setting those guys equal to each other. Set up some equations for yourself to see what you have. So 129 and 131. Thank you for listening, and come find me if you have any questions.